Hey, Vlog Nation. Okay, here we go. The essential question for today. What does it mean when two lines are parallel, intersecting, coincident, or skew? You do. You do. Okay, so the essential question that after today's notes you should be able to answer, okay, is what does it mean when two lines are parallel to each other, intersecting, coincident, okay, or skew? Okay, these will be very important vocab words. Okay, maybe even they will pop up on the next quiz as a vocabulary word. Okay. Oh, good. Do what? You are wrong. We are doing both. Yeah. It was.
I love releasing wrinkles in my brain.
Did it work?
Yeah.
That's good.
You're welcome.
Thank you. All right. Skew. 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 Like skew, skew. Okay. No?
No. It's like a word.
Pew, pew. Pew, pew. Oh, that's true. Skew, skew. That doesn't work. Yeah, you're right. You're right. Takes a big man to admit his mistakes, and I am that big man. I knew Gage was going to like that one. Okay. Letter A. Parallel lines. Letter B. Intersecting lines. And then letter C. Coincident lines. Okay, now, two of these, I would be absolutely floored if you have never heard of parallel lines or lines that intersect. Okay, but coincident lines is probably one that we are not super familiar with. So what I would like for you to do is first draw examples of A and B, okay, underneath, okay, and then discuss with the person you're sitting close to at what maybe C would be. Okay, so we have parallel lines, we have intersecting lines, and then discuss what we think maybe a coincident line would be, or coincident lines, because we are talking about two lines interacting with each other. Okay, I'll give you, I don't know, about a minute. Ready, set, go. Yes. It wasn't open when you got it, was it? It wasn't taped shut? Okay.
Is it lines that intersect and then unintersect?
I don't know. When it's meant to be, they are the same length and shape Oh, are we supposed to write Why are you doing that? Maybe twice. Please. Oh, I'm cases, what do you think like midlines are? So like this.
What? Hold on just a second.
Well, but these are just intersecting because there's points at the end. So that's
I didn't get to go trick or treating.
Oh no.
So it's just
What
a
happened?
bunch of intersecting lines.
I wasn't able to. My mom was busy studying inside the game.
Gotcha. Well, we tried to take my son trick-or-treating, and me and his mom messed up on the time and place that we were supposed to be. So,
Oh no.
yeah, he was pretty sad, and we felt terrible.
What'd you do? What'd you do?
Like, what was our mistake, or what did we do after?
What'd you do for it?
We just went around the neighborhood then. So he didn't get to do the thing that we were going to do, but he at least still got a little bit. So, but I like your hoodie. Is that a new one?
Yeah.
Nice.
I actually just got it from the school.
Oh yeah.
Yeah.
Okay, good.
It was delivered to my house in Tonka.
Oh wow.
Yeah.
So you had to wait a little bit before you get it.
Yeah, I had to wait till my dad came down this weekend.
Okay. Well, good. I'm glad you got it.
And then whenever he got back, he found out that my parents were delivering. Snickers.
Pass some candy, please. My dad won't let me go trick or treating. Please.
Stab you.
Please. You got candy over there. Please. Nuh-uh.
Maybe after class, I'll see how you do today. That's a transversal. Okay. Let's come back together and talk. Okay. Let's talk, please. Okay. Parallel lines. Somebody raise your hand. What is the kind of key attribute of two lines that are parallel, Melissa? No, they won't ever intersect, right? So I got a line right here. Obviously, if you're drawing it and you're not using a protractor, it'll be hard for you to exactly tell that they are the same angle, okay? Now, what makes them parallel? Yeah.
They don't intersect.
Sure. Why don't they intersect?
Because they're right next to each other.
Because they're parallel. Thank you. You are not wrong, but I'm looking for some more like detail. Bram.
Oh, because they're at the same angle.
Yes, but it's not the word that I'm looking for.
Uh,
Since you answered the first one, I'm gonna give it to Gray. Gray, what do you think? What do you think?
So I was thinking it was like because they are heading in the same direction.
Mm-hmm.
Exact distance from them.
You're not wrong.
I think it's the right word.
That's okay. I'm looking for something real specific. All right, Melissa.
okay, because I'll be wrong. Okay.
Cool.
Okay.
That's a great start to a story.
It's because they go on forever, but they don't like curve or like infinite.
I am looking for a specific attribute about the lines that makes them never intersect. Reese. Don't be scared. You've heard multiple
They're
answers.
straight.
Oh! There we go. Okay, so all of y'all are saying the right thing. Okay? You're not wrong. I'm just looking for something very specific. Please listen. Okay. They never intersect because both lines have the exact same slope. And slope is how you can determine the angle or the trajectory of that line, right? Which way is it going? Okay. So if this slope right here is a 2, okay, then this slope is a 2 if they're parallel. Okay. Intersecting lines means they have an intersection point. And that's it. Okay. Now, they don't have to be perpendicular. Intersecting lines can intersect at any angle. Okay. Intersecting lines are an important, one important stipulation is they can only intersect at one spot. Okay. So if they intersect at this spot, that's where they intersect. Okay. And they shouldn't touch anywhere else because otherwise you're not working with straight lines anymore. Okay. Letter C is talking about coincident lines. Okay. I saw a couple guesses that were great. Does anybody have an idea that they'd like to throw out there, Aiden? Okay, that's a good idea. Yeah. Now, if we're thinking of these lines, they're infinite. So whether we draw them as intersecting or not, they actually, imaginarily speaking, are intersecting, or theoretically speaking.
So do they have to be straight lines?
We're only talking about straight lines at the current
Dang
moment.
it, then
Yeah,
wrong.
it's a good idea. Gray, what you think?
They're along the same line.
Say that one more time.
They're along the same line.
So coincident lines are two lines that are the same. Okay, they are basically on top of each other. Okay, I didn't make it around to everywhere, but I did see a couple people that did have one single line drawn. Okay, which is perfect. Okay, so these are two lines, but those two lines are the exact same line. Those would be coincident lines. Okay, so let's talk about skew. Skew lines. We will, and I'm actually going to move this down just a little bit. Not working very hard for that candy. Okay, so letter D. We're going to talk about skew. Okay, so skew lines are two lines that.
Teachers and students, please pardon this interruption. If you are a basketball player, please note the following announcement. You have practice this afternoon. However, the scrimmage tomorrow has been canceled. Please make note of that. You do have practice today. The scrimmage has been canceled for tomorrow. Thank you.
Okay, so skew lines are two lines that do not intersect and are not coplanar lines. Okay, now coplanar is what again?
Two lines on the same plane.
Yeah, two lines on the same plane. Okay, so if we're looking at a square, all of those lines are on the same plane. So in order for us to get into different planes, we have to move to 3D. Okay, so if we're looking at this cube, which I halvesies drew by hand and halvesies cheated, it's okay. I'm comfortable with it. So find two lines that are skew lines. So they have a relationship. The relationship is that they are skew lines to one another. They cannot intersect ever. And when we're thinking they can't intersect, this is a cube. We all are in agreement that this is, I'll say, almost a cube. Okay. Now, okay, then we'll say it's a rectangular prism. How about that? There. So now, do what? No, well, you don't necessarily have to draw this. I just want you to be able to recognize it. So, oh yeah, absolutely. Hey, I haven't asked a question yet. Hold on.
Hey, dude.
What did I say?
You said give me two lines that are skewed.
Oh yeah. Let me talk for a second. So when we're thinking lines that intersect, okay, if I'm going line AD goes on for forever. Okay, even though right here it looks like a closed system, we're thinking theoretically when we're talking about lines. Okay, so the lines go on for forever. Okay. Now I want you to answer it on your paper. Not to me.
The what?
That Twizzler's going to somebody else, Lane.
No.
Okay, so are y'all both interested in the Twizzlers or the math? Both.
Yes.
There's the answer. Good. Smart,
I'm
Marley.
interested in Alfie.
Okay. You don't
Of
have to.
course.
You can, but you don't have to.
I'm just gonna put the line.
So, yeah. So you're looking for two lines that are not on the same plane and will not intersect. Are you going to answer? Hold on. What's up, Gray?
That's a tesseract.
Don't
Only,
tell
buddy.
them.
Stop it, Aiden.
Me too.
Don't do it. Move your foot.
Why is it so hard for you to just leave me alone? You gotta write the name on the line.
Plane right here, plane right here, plane right here, plane right here. Okay. So you're looking for two lines that are on the same. Basically, as long as they don't share a square, you're okay. I believe in All right, James, what you got? Say that one more time.
No.
Yeah, those are.
You said EF and
HG.
HD. Yeah, that would work.
HD and what now?
So he said EF, which is this line right here. Okay, so we have this line, EF, right? And then he said HD, which is on a different plane, right? It's this vertical line right here. Will those intersect? No. Okay. Now, if we were talking coplanar points, that one wouldn't work because E and H are on the same plane, right? But we're not talking about coplanar points. We're talking about coplanar lines. As long as the lines aren't on the same plane, they can have a point that maybe shares, okay? And that's totally fine. So then we've got DH, okay, or HD. Okay, that would work. Now, I saw a bunch of others. I saw AB and GH. Okay, that would work. Basically, it's do you have two lines that don't share a square? Okay, if they share a square, then you need to look elsewhere. Well, that rhymed. I'm a poet and I didn't even know it. Okay. So a deal that I made with geometry last year was if they got a certain grade on a test, then I would show them a video of me rapping. Y'all want to see that video?
Yes.
We have to win a whole championship this year.
Is it on YouTube?
We'll talk about what that deal looked like. Okay, let's keep going.
Somebody's gonna sneak their phone into class for that.
Do what?
Somebody's gonna sneak their phone into class so they can record you rapping.
That would not be good. Okay, so let me put this on here. Now you can draw. Listen, please. You can draw the box if you want, or if you just want to look up here, okay, then you can just use the one that I'm drawing. Sure. Okay, so we've got A, B, C, D.
A, F, C, A,
Okay, so we have a few questions that we need to answer. Okay, first, I would like for you to answer which lines fit these descriptions. Stop. There we go. Okay, so first, lines parallel. We'll just say line. Okay, line parallel to CD and containing point A. Need to change this default. And then we've got, let's go line skew to CD and containing point A. One of the 7th graders.
Honestly, probably DJ. Maybe first been out in the cold for like 3 hours. Oh, they try out. Ooh. Oh.
Okay. So do these 3 for me. So we've got okay, so we have A, B, and C. Okay, so tell me a line parallel to CD that contains point A. Letter B is tell me a line that's skew to CD and containing point A. And then letter C, tell me a line that's perpendicular to CD and containing point A. Do what?
Oh my god.
Welcome to okay.
I'll move up there. I'm so tired. I forgot particular names.
Is that better? Really?
Yeah.
Nice. Actually, this is way better. Why haven't I done this?
You've never had anything complain about not being able to see.
No, actually, I have.
Oh yeah.
I just haven't moved.
Don't care. Hey, Mr. Bennett, can I have a piece of candy inside my help because my stomach hurts? For my health.
I'm not sure that the sugar will help.
I don't know how you
From earlier?
So famished. I like pasta. Nice.
I'll think about it.
Think about it.
All right. Letter A. Who would like to answer one for letter A?
Mr. Bennett, you should just make
Claire.
pasta in B3 so that we can have it.
A, B. Perfect. Are there any other lines that you'd be able to put down there for letter A? No, because of that second little descriptor, right? It has to also contain point A. What other lines are parallel to CD?
AD. Bueno.
Yes.
DF.
HG. Yep, there you go. Okay.
DF is parallel, right?
What'd you say?
EF parallel.
To be parallel, they have to be on the same plane. Because if they're not on the same plane and they don't intersect, they're not parallel lines, they are skew. Okay, so letter B. Bram,
Yeah.
what'd you get for letter B?
Yeah.
A skew line to CD.
A-E.
A-E.
IOU.
That would work. Okay, letter C. A line perpendicular to CD and containing point A. Chazelle.
After death.
A. D. Good. Okay, any questions? Gray, you got a question? No, you're good. Okay, Let's move on. Skip ahead. Skip ahead. Skip ahead.
If you keep on skipping,
Skip
I'll skip your
ahead.
class.
Skip ahead. There we go.
You like Mr. Bennett too much, Jesus. Mr. Bennett is pasta.
Mr. Bennett, never took a line over 8. What?
What?
Don't make me tell you. Oh. Yeah, thank you. We put like a cell line separating. No one else.
Mr. Bennett.
Yeah.
I
What do you say, Claire?
You could line this up.
Yeah. That's a good idea, actually. Okay, next section. This I do prefer. I would prefer for you to draw this, please. So,
What? Is that an A? You're...
okay, so we're going to talk about angle relations a little bit more. Okay, now that we've talked about parallels, now these are angles formed by a transversal. Okay, so a transversal. I'll just type it up here. A transversal.
Is this 3D?
This is 2D. Yeah, one plane. So a transversal, okay, is a line that intersects two or more coplanar lines at different points. Yeah, that. There we go. A line that intersects two or more planar lines, coplanar lines, at different points. Okay, so, and this actual definition kind of goes along with the question that Bram just asked. Bram was asking if this is 3D or 2D. Okay, this is two-dimensional, and I can make this bigger.
My
Apologies.
perspective is gonna get wrecked this year because of this class.
Okay, so this is a two-dimensional figure.
No.
Okay, we're just on one plane. We have two lines. Okay, going kind of more vertically than horizontally. Okay, then you have one single line that cuts through both of them. Okay, that line is the transversal. Okay, so what we get when we have transversals is we make angle relationships because it's now creating a bunch of different kinds of angles. Okay, now what are our angle relationships?
1 and 6 are equal. 2 and 5 are 10.
What are their names?
Oh, well,
Okay, so we have.
Wait, how do you know 1 and 6 are equal?
Oh, wait. Are
We have corresponding angles.
Equal. 5 and 8 are equal. 1 and 4 are equal. 3 and 2 are equal.
Oh, yeah. 4.
No.
Vertical angles will be one of them, yes, but we have some that we need to talk about that we haven't talked about yet. Okay, so I could really use y'all's attention because I don't think we know this yet, and we need to talk about it. Okay, so corresponding angles appear when they have corresponding positions. So what that looks like is like if we look at angle 2 and 6. Okay, they are on the transversal. Are they both on the same line? 2 and 6. Yes. Okay. So these are corresponding angles because they are both on the transversal. Okay, and they are both on what side of the line that they are a kind of an angle with, I guess.
Upper.
Yeah, they're both on the right upper side, right? Okay. So that's be corresponding. So what would be the corresponding angle? So corresponding angles, angle 2 and angle 6. Okay. What else would be corresponding angles?
5 and 1.
5 and 1. We're getting there.
3 and 7 and 4 and 8.
Yeah. Okay. So they're angles that along the transversal are kind of in the same position, but on the the two other lines. Okay, that are going in a different direction from the transversal. Okay. We would also have alternate interior angles. Okay, alternate interior angles are going to be angles that kind of lie on the inside, okay, because we're talking about interior. So what we're really looking at are, if I'm talking inside versus outside on a transversal, these are the inside. Okay, those are the interior. So alternate interior angles would be 7 and 2. Alternate interior. Okay, so angle 2 is an alternate interior with angle 7. Okay, angle 5 would be an alternate interior to angle 4. Okay, we'll also have alternate exterior. Okay, so if we're talking exterior, now we're talking about these outside and these outside. Okay, so Lane says alternate exterior angles would be angle 3 and angle 6. Does anybody agree or disagree? Agree.
Mr. Bennett,
Angle 3 and angle 6.
we have corresponding interior. Is that the thing? Oh my gosh, I'm so sorry.
Okay, now we don't corresponding interior.
Or is it called something different?
Oh no, we'll call it something slightly different, but you're thinking along the same lines. See what you're saying? Okay, so what would be the other alternate exterior? Yeah, angle 1 and angle 8. Okay, so and then this thing is a little bit more user friendly. We will also have consecutive interior angles. Okay, and the consecutive interior angles would be, we're thinking now inside, okay, because we're interior, but it's now no longer looking like diagonally this way. We're looking consecutive, so it's going to be 2 and 5. Okay, 2 and 5 are going to be consecutives. So what else would be in consecutive interior? Angle 4, angle 7. Okay, so let's kind of keep this going. And I'm actually not sure that we will talk about this one even today. But could we have consecutive exterior angles? What would they be?
1 6.
There you go.
1 6 and 3 8.
Consecutive exterior angles would be angles 1. Come on. Well, there we go. Okay, angle 1 and angle 6, and we'd also have angle 3 and angle 8 would be consecutive exterior, right? So, how do we feel? Does it feel?
I feel good.
I don't have much more left. Okay.
I like your hat. Yes, are you stupid? You forgot to write all of the notes.
It's like
Mr. Bennett.
320.
Ooh.
So this was a transversal. I want to talk about parallel transversals, and then we'll be done.
Why did you ask? You're such a goofy goober.
Goofy goober sounds redundant. Is a goober not goofy by nature?
It's from SpongeBob. A goofy goober is from SpongeBob. Huh?
Bigger. Okay. So where we will use those transversal relationships specifically will be right here. So now we're talking about parallel transversals. Okay, so we have two lines that we will say are parallel to each other. Okay, how they note parallel lines, and some of y'all have seen this on previous things. Okay, they will put little triangles that match. Okay.
Like little lines, like little dashes.
Typically, the dashes deal with um, length rather than slope.
Okay.
Yeah. So parallel lines will typically be identified with the two little matching triangles. It's okay. And then what makes it a transversal? A line through it, right? So again, let's number. We've got 1, 2, 3, and 4, 5, 6, 7, and 8. Okay, now when it comes to parallel lines using transversals, you will have to use all of these angle relationships to find appropriate measurements. Okay? So let's think about this. If these two lines are parallel, that means they are at the same slope, right? Same angles. Okay? Which means now when we have corresponding angles, what do we know about their measurement? They should be equal. Good job, Lane. Okay, so corresponding angles will be equal to each other, which means angle 1 will equal angle 5. Yep. Yes. Okay. So that was corresponding. So we also will have alternate interior. Okay, so when we have Okay, so when we have alternate interior, give me two angles. What two angles are alternate interior angles to each other? 4 and 5, because 2 and 5 would be consecutive. Okay, so 4 and 5 are alternate interior. Okay, so what do we know about their angle relationship? They should be equal as well. Angle 4 will be equal to angle 5. So now the measurement to just one angle, like angle 5, okay, will give you the measurement for angle 1, which will also give you the measurement for angle 4, okay, and you might even have some others. Okay, so let's look at letter C. Letter C Oh my gosh, this thing is. Okay, I'm gonna wait for this to come back, but it'll come back. So for letter C, we have alternate exterior. Okay, so go ahead and write that down as soon as you're able. Okay, there we go. Yeah, it came back. Okay, sorry. It messes up in this class more than any other class. Honestly, it might just be because it's like it's sleepy. Okay, alternate. Alternate exterior. Okay, alternate exterior. So which two could be?
No.
6 and 3 would be good ones. Okay. So what do we know about 6 and 3? They would be equal. So we've got angle 3 is equal to angle 6. And then letter D. Okay, consecutive interior. And consecutive interior would be what?
4 and 7.
4 and 7 would be consecutive interior.
Oh, 3 and 8. Oh, I mean 4 and 7, 8 and 2 and 5.
Uh-huh. So what would those tell us?
Wait, no. Nobody else is answering. You can slow down. Oh.
Well, let's just now I would typically say like you can't just look at it and make a determination. However, we can look at it and see if we think that they are equal to each other.
They are not.
It doesn't look like they're equal to each other. Yeah, one's acute and one's obtuse, right? Okay. Now, what do we know about angles that are?
Oh, combined, they're both equal 180.
I like where your head's at. Yes.
I said that.
So, consecutive interior as well as consecutive exterior, okay, will be added together to equal 180. So angle 4 plus angle 7 equals 180. Okay, those are consecutive interiors. And then we could say that angle 3 and angle 8 equal 180.
Can you grasp this one? I would show you. I'll show you. I need a piece of grass.
Okay, let's do a practice. No, this one's kind of a part of this section. So we have two parallel lines. With a transversal. Exactly. Just trying to throw you off. Okay, so you have 4. That's angle 4. This one has a measurement of 115. And then this one down here, let's do x plus 5. Okay, so we have line A, line B, and line C.
Are A and B parallel?
A and B are parallel.
Why? Did you hear it? Oh, this is easy.
Okay, so we are going to solve for x. Listen, please, listen. I just want to talk to you about it, and then I actually just want you to go and do it. So we're going to solve for x. So what you have to do first is identify relationships. Identify angle relationships, okay? What's the relationship between 115 and 4? Maybe not on our notes from today. Yeah, they're vertical angles. So you'd want to get out your notes from from the corresponding angles and angle relationships worksheet. Okay. Then you can identify the angle relationship from 4 and x plus 5. Okay. I want you to work with someone you're sitting close to and see if we can figure it out first.
Oh, I already know this. You can just do this before. Okay.
It is a 4. It's just naming it though. It's not 4 degrees. Here, maybe I should do this. No, I gotta keep it. I gotta keep it a number. So I'll leave it at 4. Yep.
I probably got it wrong. I got 3 questions wrong, bro. And the last one was something that.
I know what x plus 5 equals.
What's up?
Wait, are we
I don't
solving
think
for
she
x?
deserves candy.
Oh, I already know it.
Oh yeah.
I'll leave that to me.
Mr. Bennett, I know what x is. I think I've used my pencil.
So proud of you.
Do I get to twist it out?
I figured it out first. It's easy.
What do you mean I figured it out?
What'd you get?
I got 65 is the whole is that. It's the whole thing. But 60 equals x.
Nice. Good job.
I get just after.
Do what?
I get just after.
Yes.
Okay, so these are also going to be 115 because they're, and then 115 plus 75 is 180, and then 75 or 65?
It's 75.
No, I think 65.
Which one? It's
60.
no,
115 plus 65.
it's 75. 150. Oh.
There you go.
So it's
You'll
60.
figure it out. There you go.
105 would be plus 85.
330.
Hey, Mr. Bennett,
I found out the angles.
is that thing on the top right is 7?
4 plus 7.
It doesn't look like a 7. It looks like a diamond without one side. Come on, man. A line is 180 degrees. Giselle, why are you dying of laughter again? Oh, Mr. Bennett. Mr. Bennett. Mr. Bennett. Alright.
So, Mr. Bennett, in Spanish class, Mr. Owens was saying that she has a skirt on underneath me, and he drew a skirt. He said it in Spanish, and so he drew a skirt on the board so that we knew what he was saying. And Lily says, "Why does the skirt look like a lampshade?" And Mr. Owens said, "Because Giselle looks like a lamp."
Wow. Wow.
And then I said she's about the right height.
Okay, let's look at it. Come back, please. Let's come back together now. 3, 2, 1. Okay. So we determined that 115 and angle 4 are vertical angles to each other, which means they equal each other, right? So we know that this is 115. Okay. So hopefully we could get that step. Once we get that, we see that these are consecutive interior angles. So if we take 115 and then add it to x plus 5, that should set equal to 180. Okay? So then you've got x plus 120 equals 180. Then I'm going to get x by itself by subtracting 120 from both sides. Now, I'm aware that this aspect of the problem is simple, but I've seen you guys solve equations and we're not good at it yet. So you not paying attention right now is a mistake on your part and not mine, because I already know how to do this. Now, first of all, if we're solving equations without writing any of this out, you're wrong. And I had a struggle last year getting geometry students to write out their work. I'm not sure at what point we feel like we're too smart to have to write stuff down. The smartest mathematicians, engineers, scientists in the world write everything down. Well, type it. Okay? You need to be writing this stuff out. So, and if you're not, you're getting to the point in your math where you're not going to be able to get away with it anymore. Okay? Because what I cannot guarantee you is that you'll have stuff in algebra 2 that you won't have to write down. Okay? You will. You'll run into stuff that you can do in your head and you'll be fine. But when you get to trig and calculus, you will not be able to do that. Okay? College trig, college algebra, and calculus will be one problem is 1 page long. And it will be you're using every line going down. Okay? And if you don't build the habits now of writing stuff down, you are going to be on the struggle bus when you get to that class. Okay? I have students that I had last year right now emailing me all the time asking for help on that stuff, on that kind of stuff, okay, that are in high school now. So build habits. Don't think you're too good to write stuff out just because you don't want to waste the time, I guess is what it is. Yep. Absolutely. You're welcome. Okay. X is 60. That's what we should have gotten. Yeah? Okay.
It's not a five. It's not an odd number in
Yeah.
there.
I feel like I did this once.
Yeah? Why'd you do it?
I just minus 115 from 80, and whatever was left, x plus 5, so I just minus 5, and then I got 60.
You did the same thing? Yeah, you did the same thing. Your process was just slightly different, but yeah, you did the same thing. Okay, yeah. Okay, so here's what I want you to do. Since it seems like we're doing okay on this, I would like for you to go ahead and go to your homework.
What's our number?
In CUDA.
Cuda.
In CUDA. Now, because it's already 3:40, you might run out of time to finish. Okay, but I set the due date for Friday, so you should have time in class on Friday or after class out of here. But we need to work on it right now. Yeah, if it's got staples in it.
I killed 19 people.
We all know that. I see staples. Try it out.
Okay, so your homework has 2 questions. It has 7 questions regarding these parallel transversals. And then it has 3 questions working on angle addition postulate. Okay, because we need to continue to work on that.
Every time I close my Chromebook, it shuts down.
Nice. Don't shut it.
Huh?
Said don't shut it, I guess.
It's gonna die so fast.
Well.
I realize that it's a me problem, but I need